So we're still dealing with dihedral angles. The only difference is we're going to be using the rebatment method. We're still using the same triangular base pyramid and the same measurements, and we're also using the same line of intersection and the same surface as that. So we want the dihedral angle between surfaces A and C. Now the way we're going to do this, using the rebatment method, you're basically inserting a cutting plane that will just cut right into there and will give us the dihedral angle. So if you can imagine, this was a saw that just saw straight through, perpendicular to the line of intersection, and you will actually come out with something like this if you were to cut straight in. So if you went, that's what you get, and in there is the dihedral angle. So the way we do this is very simply, we get the true length of the line of intersection once again. So we know how to do that at this stage. We know we have to look perpendicular to the line of intersection. So that's point O still the side. So we know that point O is at this height up here. Now I'm not using my compass once again because it will damage the board. So there you have point O. And there's O. Actually, sorry, we should really set up our X, Y1 first. This is your X1, Y1. And we know that point O is this distance, or is this height. So I can write that in. And we know that 1 is on the ground line. So there we have 1. And very simply, we just join those two. So there you have the true length of the line of intersection. Right, simple. Now we need to introduce our cutting plane. So our cutting plane is going to be, as I mentioned previously, it's going to be perpendicular to our line of intersection. So it doesn't matter where you put this. So I'm just going to slot my cutting plane in there. Now bear in mind, it must be perpendicular to the line of intersection. Okay, so the next step is you need to we need to flatten that down. So right now we have our cutting plane in, but it's not, we can't get to the dihedral angle because it's not on the baseline, it's not on the XY. So we need to rotate it down. Very simply, you guys will use your compass like this, but I'm just going to draw it in freehand, the same mark as a compass would. Right, perfect. So there we have it. There's our triangular cutting plane on the ground line. We need to bring that then back. Like so. So originally our cutting plane was sitting up, well, it would have been sitting up before we flattened it down. It would have been sitting up here, right? But that's not the true dihedral angle, because that cutting plane is still, if you were looking at it here, it'd be sitting up at an angle. We want our cutting plane to be flat on the ground, so that's why we do this here. So we rotate that down, bring it back, right? So get rid of that when it's inclined and when it's flat. There you have it there. So inside there is the dihedral angle. So basically, to recap, you want to get a true length of the line intersection. You then want to insert a cutting plane. So there's our cutting plane sitting right in there. So if we introduce our cutting plane, and then we want to do is rotate the cutting plane so it's flat, and then by flattening it onto the base, onto the ground line, it'll give us the true dihedral angle. So that's how you get the dihedral angle between two surfaces using the rebatment method.